Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 2 to the power of 24. So to solve this, I'm going to first start by rewriting 2 to the power of 25 as 2 to the power of 24 plus 1. So I have this minus 2 to the power of 24. And the reason I did this is because we want both of these to be the same. We want to have 2 to the power of 24s. So the best way of changing 2 to the power of 25 as 2 to the power of 24 times something is to rewrite this as 2 to the power of 24 plus 1. So now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So now 2 to the power of 24 plus 1 turns into 2 to the power of 24 times 2 to the power of 1. And I still have this minus 2 to the power of 24. Now, from here, what I'm going to do is factor out 2 to the power of 24, because notice how both of these terms have 2 to the power of 24 in them. So, I get 2 to the power of 24 times 2 to the power of 24 times 2 to the power of 1 divided by 2 to the power of 24 is just 2 to the power of 1. And negative 2 to the power of 24 divided by 2 to the power of 24 is just negative 1. So I get 2 to the power of 24 times 2 to the power of 1 minus 1, which is equal to 2 to the power of 24 times 2 minus 1, which is equal to 2 to the power of 24 times 1. And this is just anything times 1 is obviously just equal to itself. So this is just equal to 2 to the power of 24. Now, from here, I'm going to rewrite this as 2 to the power of 12 times 2. So, the reason I did this is because I can now use the property a to the power of m times n is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is equal to 2 to the power of 12 to the power of 2. And 2 to the power of 12, well, 2 to the power of 1 is equal to 2. 2 to the power of 2 is double of 2 to the power of 1, so 4. And 2 to the power of 3 is double of 2 to the power of 2, which is 8. So this pattern goes on, and I keep on doubling this. Until I reach 2 to the power of 12, which is equal to 4,096. So this is my value for 2 to the power of 12. So now I get 4,096 squared. Now, what most people would do, well, first of all, 4,096 squared is the same thing as 4,096 times 4,096. And from here, what most people would do is they would just multiply this like this. So they do 4,096 times 4,096 and use the conventional method to multiplying it. However, this method takes way too long, and it's really easy to make an error using this method. So instead, to more easily solve this, I'm going to rewrite this as 4,000 plus 96 times 4,000 plus 96. And now I can use the distributive property. So I get 4,000 squared plus 4,000 times 96 plus 4,000 times 96 plus 96 squared. Now, from here, $4,000 squared, well, this is simple because all we have to do is 4 squared, which is 16, and then 1,000 squared, which is a million. So a million has 6 zeros, so all we have to do is add 6 zeros to the end of this. So I get 60 million, it's 4,000 squared, plus 4,000 times 96. Well, 4 times 96 is 384, so then all we have to do is add 3 zeros to that. So I get 384,000, and then this should be 4,000. So plus, again, 4,000 times 96, which is 384,000, plus 96 squared, which is 9,216. So now all we have to do is add all of these up, which is fairly simple. So I get 16 million plus, let's first start by adding up 384,000 plus 384,000. So that's going to be 768,000 plus 9,216. And now this is equal to 16 million plus 768,000 plus 9,216, which is 777,216. And now for my final step, I just have to add this to 16 million. So we don't have to worry about the millions place, so I just get 16,777,216. So this is my answer to this problem. Now, if you haven't already, please make sure to subscribe and leave a like because I have many more videos like this on my channel, which you guys can try to solve. And if you're up for challenges, I have a bunch of those as well. So please make sure to subscribe, and thank you. Bye. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So to start, I'm going to factor out 5 to the power of x from my left-hand side. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now 1 plus 1, that's equal to 2, so I have 5 to the power of x times 2 is equal to 7. Now I'm going to divide both sides by 2, so then these two cancel out, and I get 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So now I have x times log 5 is equal to log 7 over 2. Now I'm going to divide both sides by log 5. These two cancel out, and I get x is equal to log 7 over 2 over log 5. Now if I have something in the form log a over b, this is equal to log a minus log of b. So in this case, I've logged 7 over 2, and I can rewrite that as log 7 minus log 2, and I have this over log 5. So now that this is all simplified, all we need to do is plug in the values of log 7, log 2, and log 5. So log 7 is equal to 0.8451. Log 2 is equal to 0.3010. And log 5 is equal to 0.6990. So I have x is equal to 0.8451 minus 0.3010. And I have this over 0.6990. So if we simplify all of this, we get that x is equal to 0.7784. Alright, so in this problem, I have x to the power of 4 is equal to 1. So I'm going to first start by subtracting 1 on both sides. So then these two cancel out, and I get x to the power of 4 minus 1 is equal to 0. Now x to the power of 4, I can rewrite this as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, I can write this as x to the power of 2 to the power of 2. Now I have this minus 1 is equal to 0. Now 1 is the same thing as 1 squared. So I have x squared to the power of 2 minus 1 squared is equal to 0. If I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 1. So I have x squared plus 1 times x squared minus 1, and this is equal to 0. Now, remember how now this is equal to, this actually gives me two equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So for x squared plus 1 equals 0, I'm going to start by subtracting 1 on both sides. So these two cancel out, and I get x squared is equal to negative 1. Now if I take the square root on both sides, the square root of x squared is x, and the square root of negative 1, if you guys already know, is I. So I have positive negative I. And for x squared minus 1 equals 0, I'm going to add 1 on both sides. So I get x squared is equal to 1. If I take the square root, I get x is equal to positive or negative 1. So that's 2 more solutions. So these are my 4 solutions to this problem. Alright, so in this problem, I have x to the power of x to the power of 10 is equal to 400. So to start, I'm going to rewrite 400. Actually, before that, I'm going to rewrite 400 as 20 squared. And now I'm going to take the power of 10 on both sides. So now I have x to the power of x to the power of 10 to the power of 10 is equal to 20 to the power of 2 to the power of 10. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So in this case, we can think of x to the power of 10 as m and 10 as n, and I can switch these two places. So now I have x to the power of 10 to the power of x to the power of 10. And also, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as 20 to the power of 2 times 10, which is 20. Now I'm going to let x to the power of 10 equal to the variable y. So now I have y to the power of y is equal to 20 to the power of 20. And a to the power of a equals b to the power of b. This means that a equals b. So y is equal to 20. Now remember how we let x to the power of 10 equal to y, meaning x to the power of 10 is equal to 20, and x is equal to the 10th root of 20.